Put an average human in a cage against a chimpanzee of the same weight, and it's not a fight, it's an accident. A chimp can tear your finger off without even trying. We have no claws, no fangs. We can't outrun almost any serious predator. And yet this fragile species ended up ruling the entire planet. We built rockets, cities, power grids. We domesticated wolves, sea lions, even entire insect populations. How is it possible that the weakest animal in the animal kingdom, compared to its closest relatives, is also the one in charge? The answer isn't the one you've probably heard, and it's far stranger. Here's what most videos on this topic won't tell you. Our weakness wasn't an evolutionary mistake. It was, quite literally, the plan. And the proof is hidden in things as specific as a broken gene in our jaw, a cat-sized nocturnal mammal that shares our muscle type, and human babies born more helpless than any other primate on Earth. Let's take this apart piece by piece. You've probably heard that a chimpanzee is 5, 8, even 10 times stronger than a human. It's one of the most repeated facts on the internet. It's false. When scientists finally measured chimpanzee muscle fiber by fiber in a lab, not anecdotes, not viral videos, but actual biopsies, they found the real difference is far more modest than people assume. Only about 35% more force and power output, not several times more. The super strength myth traces back to reports from almost a century ago that were never directly tested, until now. But here's the interesting twist. If the difference is that small, why do we still lose in a physical matchup? The answer lies in the type of muscle fiber, not the amount. Chimpanzee muscle is made up largely of fast twitch fibers, the kind that generate short, explosive bursts of raw power. Human muscle, by contrast, is dominated by slow twitch fibers, built for endurance, not instant power. In other words, we didn't lose strength by accident. We traded it. Evolutionarily, we were selected for chasing prey over long distances, not for winning a strength contest in seconds. Walking and running long distances, something almost no other primate does well, turned out to matter more for survival than being able to beat a chimp in an arm wrestling match. And here's the detail almost nobody mentions. If you search the entire planet for which other mammal has the same muscle fiber distribution as a human, dominated by slow twitch fibers, you won't find another great ape. You'll find the slow loris, a tiny nocturnal primate, painfully slow, that creeps centimeter by centimeter through the branches. Stop and think about that for a second. The animal we share the most muscular similarity with out of every mammal on Earth is literally famous for being slow. This one gets even stranger. About 2.4 million years ago, a gene called MYH16 stopped working in our ancestors. That gene is responsible for powerful jaw muscle in nearly every other primate. In macaques, for example, jaw muscles are up to 10 times more powerful than ours. 10 times. But here's the part that changes everything. Some scientists believe this loss of jaw strength wasn't just a disadvantage. It may have been the key that allowed our skulls to grow. A weaker jaw means less muscular tension pulling on the skull, which may have freed up physical space for the brain to expand over time. Think about that. Losing bite force may have indirectly been one of the events that made us smarter. Here's something almost never discussed outside very specific scientific circles. Chimpanzees and bonobos are two genetically close species with radically different personalities. Bonobos are far less aggressive, more social, and keep more juvenile physical traits into adulthood. Scientists have noticed that the differences between bonobos and chimpanzees closely mirror the differences between a wild animal and its domesticated counterpart. That's why bonobos are sometimes called self-domesticated. And here's the unsettling part. Modern humans show the exact same pattern, just taken to an even greater extreme. Sometime between 40,000 and 25,000 years ago, our species went through an accelerated process of self-domestication. Our faces got softer, our skulls changed shape. We literally became a tamer version of what we used to be. This sounds like conspiracy theory material, but it isn't. The human skull has been shrinking over the last 40,000 years, and more sharply over the last 10,000. The leading explanation isn't that we're becoming less intelligent. It's that we've been selected, generation after generation, to be more social, more cooperative, less aggressive. Essentially, the same evolutionary force that turned wolves into dogs may have been slowly turning us into a more domestic version of ourselves. Now to the most extreme point of all. When a human is born, its brain is only about 30% of its adult size. In other primates, that number sits closer to 45–50%. A human baby can't even hold up its own head. It can't cling to its mother the way a chimpanzee infant instinctively does from day one. It can't regulate its own body temperature well. It needs round-the-clock care just to survive the first week of life. No other primate on the planet is born as radically helpless as we are. Here's the twist almost no video on this topic includes. For decades, the official explanation was simple. Walking upright narrowed the female pelvis, which forced babies to be born early, incomplete, just to fit through the birth canal. It sounds logical, but more recent research is directly challenging that idea. Some studies suggest the real limit isn't pelvis size at all. It's the mother's metabolic limit. The body simply can't sustain the energy cost of growing the fetus much longer inside the womb. In other words, the explanation most people take for granted might not be the real cause, and scientists are still actively debating this. And here's perhaps the most important idea in this entire video. That extreme helplessness of the human baby wasn't just a weakness we had to overcome. It may have been, in itself, the engine that drove our evolution. A baby that needs that much care forces parents to be more attentive, more intelligent, more cooperative with each other. That constant need for help may have been one of the pressures that pushed our species toward bigger brains and more complex societies. So, next time you think about how physically weak we are compared to almost any other animal, remember this. We didn't lose strength by accident. We traded it, gene by gene, fiber by fiber, generation by generation, for something else entirely. Endurance instead of power, cooperation instead of aggression, brain instead of jaw. We were never the strongest animal on the planet. We never had to be. We turned out to be the only one who didn't need to be.